the x value for -3?
Oh, this one?
Yeah.
Has to be exactly in the middle.
So it's pi?
So, no.
No.
In the middle between 0 and 5 pi over 3. So it's exactly 5 pi over 6.
Okay.
So you have to divide the interval between, that's why it makes it a little bit difficult, because the complete period is 5 pi over 3. So you have to divide 5 pi over 3 by 2, and then right in the middle you find where the minimum is. Is that better? Because we know the graph of cosine has to look like this. Very good question. Should we look at another?
Yes.
Very good. What about this one, 22? On 656, f of x equals 4 sine pi over 2 x minus 3 plus 7. Okay, so we're asked the same things. Graph one complete period, determine the amplitude, determine everything about it. Okay, so first of all, the amplitude will be the absolute value of 4, which is 4. What about the period? Since we're talking about sine, this will be 2 pi divided by the number that multiplies x, which is pi over 2. So the period for this function will be 4. Any questions? The phase shift is what we subtract or add to 3. So it will be a right 3. So the phase shift is 3, bless you. Now there is also a up 7, right? So this function will go up 7. So a vertical shift of 7. Since this is not a reflection, we know that the graph will look like this. But of course, some transformations in there will happen. Okay.
So we don't even distribute them?
No, we don't. Actually, normally this should have been given to us like this. And then we would have had to factor out pi over 2. But they're nice this time, and pi over 2 is already factored out. Okay, perfect. So what is the maximum value of this function? Now you have to be careful, because the function goes between -4 and 4, but it's an upshift of 7. So the maximum will be
11.
Very good. So the max is 11. And what is the min?
-11.
No,
No.
careful, careful. Because so it's between 4 and -4. So we move -4 up 11. Yes, up 7. I'm sorry, up 7. So from -4, so it will be positive. Excellent. Minimum is 3. Maximum is 11. The period 4. And there is a horizontal shift of 3. Okay, ready? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3 is here. Horizontal shift of 3. 1, 2, 3. So the function starts at 3. So it has a horizontal shift of 3, right? It starts at 3, and the period is 4. So everything has to happen between these. Again, we said the maximum will be 11. And where does it start? It has to be exactly in the middle. So 11 minus 3 is 8. Right? Where's the middle? So I have 4 more, correct? So this is the middle. Right? So 3 plus 1, 2, 3, 4. Correct. So the function starts here and has to end here at the same point. It has to reach a maximum of 11. So it has to be something like this, and a minimum of 3. So somewhere here, the function has a minimum. Somewhere here it has a maximum. It has to be in the middle, where it crosses again here. There is no discussion there. So right here at 4, the function has to go up, down, and back here. There is no reflection of this graph with respect to the x-axis, so it keeps its shape as is. It has no x-intercepts. It will have y-intercepts if you continue with many periods, of course, but not an x-intercept. The minimum is 3, maximum is 11. And right here in the middle, it has to reach the maximum, and right here in the middle, it has to reach the minimum. And this is the graph. These are symmetric functions. And this is the graph of f of x, 4 sine pi over 2, x minus 3 plus 7. I would like to talk a little bit about the inverse functions, the inverse for sine, cosine, and tangent. Any questions? Yes, please.
So what's the reason behind taking 7 on that?
Say it again.
What's the reason behind taking
How did
7
I get
on that?
7?
Yeah.
The period is 4. And the graph starts at 3.
So you start where the shift is?
Yes. Yes. Does the function exist on this side? Of course. Does the function exist on that side? Of course. Of course. But they want us to present 2, but I'm happy with 1 period. It has to start at 3 and it has to end at 7 because the period is 4. Is that better?
You're just adding 4 with 3.
No, the period is over there. Yes. So I start at 3 because that's the right shift of 3. And the period is 4. So 3 plus 4 is 7. Better?
So that's a general rule. Like we're just adding.
Yes. If there is a horizontal shift.
Oh.
In the previous example, there was no horizontal shift. So we had to start at 0. There was no horizontal shift, we had to start at 0. But this one has a horizontal shift of 3. So we have to start at 3 and we have to add its period. And if I go from 7 to 11, I'll have the same graph again. If I go from 11 to 15, I'll have the same graph again.
Right.
Better?
Yep.
Very good. Yes. Sarah?
Where did the 3 come from?
This one?
No, on the y-axis. On the y-axis.
Oh, because we determined that the minimum is 3. Remember, the graph is between -4 and 4. Let's do it again. Maybe there's an error. Maybe you see something and I don't. So because it's between -4 and 4, when you add 7 to -4, you get 3. When you add 4 to 7, you get 11. Is that better?
Can you repeat this, please?
Yes. Which one?
Like the 3 on y-axis.
On the y-axis?
Yeah.
So we know that the amplitude is 4. Forget about the upshift of 7. We know that if there is no upshift, the function has to exist between -4 and 4. That's the amplitude, right?
Yes.
So if we shift the graph 7 units up, the -4 moves up 7, and the 4 moves up 7.
Okay. got it.
Better?
Yep.
Perfect. Okay. 10. Okay, let's look at inverse functions. Inverse, trig, functions. Okay, all I would like to look at is the sine inverse, x, cosine inverse, and tangent inverse. The most important one that you will see frequently in calculus and beyond is the tangent inverse. So I'd like to start with that. If you remember, a few minutes ago, we graphed this function. We said x equals negative pi over 2 and x equals pi over 2 are vertical asymptotes. And the graph of tangent is this. We defined it between negative pi over 2 and pi over 2, especially when we talk about its inverse.
I have a question.
Yes, please.
Is tan inverse the same thing as cotangent?
No, that's what we said, yes. So tangent inverse is the notation, I didn't say tangent to negative 1, so tangent inverse is the notation for the inverse function of tangent. So for example, here, these are two inverse functions. F of x equals twice x, and f inverse is x over 2. But this does not mean 1 over f. So when we talk about the function tangent and tangent inverse, we only mean that this is the inverse function of that. We don't mean 1 over tangent. But it can be confusing. I completely agree. So bless you. So normally we have another notation. We have arc tangent x, in order not to confuse the tangent inverse. And when I write test finals exams and quizzes, I prefer this notation because I don't have to use the power. So this is a very useful notation. In order not to get confused and say tangent inverse is 1 over tangent or it's cotangent, then we can use arc tangent just to make sure that this is clear. Is that clear? So this is another notation for arc tangent. And for example, sine inverse of x is the same thing with arc sine x. Just to make sure that there is no confusion here. Okay, so coming back here, if this function has vertical asymptotes, what do you think that its inverse function would have? Right. So remember how we graph the function and its inverse, right? We graph, what is this? Excellent. And we reverse the whole thing and the points. I should not put it on the same, because if I put it on the same coordinate system, I have to make sure that they intersect at the same point. So where the, the difficulty with graphing tangent and its inverse on the same coordinate system is this. The units here are in radians. The units here are in integers. So in order to move everything, then this vertical axis now, the y-axis, has to be measured in angles, in radians. And so this would be in radians and this would be in numbers. So I normally avoid to put both, but on the same coordinate system, because I have to change the units. Right? So now here we have y equals pi over 2, and we have y equals negative pi over 2, and this is the graph of arc tangent. So this is arc tangent x. I want to show a few things here and how we apply and how we use inverse trig functions. Okay. On page 686, for the following exercises, evaluate the expression. So I would like us to choose from here. Here we have to use a calculator. We don't have any capability of determining those. For the following exercises, find the angle theta. So after we do this, I'd like us to talk about an inverse function applied to sine, or et cetera, et cetera. So don't think about those right now. So let's go back. So here we are given, we're asked sine inverse of the square root of 2/2. Oh, you know that immediately. You don't even have to think. Which angle has sine the square root of 2/2? I'm done. 5/4. 5/4. These are more difficult, and we'll choose from those. What about this one? Very simple. What angle has tangent 1? 5/4. The only nice one, I would say. Also this one, I have no difficulties there. Cosine inverse of 1/2. Which angle has cosine 1/2? No problem. It's the bottom one. The bottom one is the largest one. 5/3, exactly. So we know that this is no problem, 5/4. No problem, 5/4. No problem, 5/3. Okay, now let's choose from any of the others. We want to choose which one? 9? Very good. So this is 9 on page 686. We're asked to find the sine inverse of -1/2. Before we even attempt this, on the side we will write sine is defined on -π/2 to π/2, taking values between -1 and 1, as we did a few minutes ago. And sine inverse is defined on -1 to 1, which is true, it's correct, and takes values between -π/2 and π/2. Since we're talking about an angle whose sine is negative, I have to choose a negative angle. And that negative angle has to be between -π/2 and π/2. So sine inverse is applied to a number between these two, and I have to come up with a result that is between -π/2 and π/2. Obviously, it cannot be an angle in the first quadrant. It has to be an angle in the fourth quadrant. It has to be a negative angle. Which angle will do the trick? Which is also negative. So -π/6, indeed. Awesome. Exactly. So the answer of this is -π/6, because this is the angle that lands in the -π/2 to π/2. It has to be a negative angle, and it is in the fourth quadrant.
What is -π/2? Is it?
So -π/2, -π/6.
No, -π/2. Like π/2 is the 180.
Okay. So
No, π/2 is 90.
this is -π/2. This is -π/6. So in short, every answer for sine inverse has to be here. Every answer for sine inverse must be found between -π/2 and π/2. You can never say again.
Cosine would be the other side then.
No, cosine is this.
Oh, okay.
Cosine is between 0 and pi. Okay, the next one. We need more here.
Can we do 11?
Yes, 11. Tangent inverse of negative the square root of 3. So let's take a look at the unit circle. The answer for tangent must be here. How come that I put those open points in there? Tangent is undefined. π/2 and -π/2. So sine, the answers for sine inverse have to be between this and this, or between this and this, it doesn't matter. But here they cannot be these two, ever. Because tangent is undefined. So first of all, we're asked to find tangent inverse of a negative number. Obviously, it's not gonna be in the first quadrant. It has to be an angle here. Correct? And then you'll say, but you told us not to think in those terms. You told us not to determine what that is. There are only two possibilities. This could be 1/2 over the square root of 3 over 2, or it can be the square root of 3 over 2 over 1/2. Which one is it? The square root of 3 over 2 over 1/2, which is the second angle, the bottom angle, pi over 3. So the answer is negative pi over 3. So one more time for
Can you show
tangent.
using like a triangle?
Say
In that
again.
angle?
You can if you want. Yes, please.
One pi over 3 0.
Yes, it's not in the domain. Very good point. I didn't write the domain for tangent. Sorry about that. You're right. I did it for sine, but I didn't write it for tangent. Let me write the domain and the range for tangent. Thank you. So tangent is between negative pi over 2 and pi over 2, taking values between negative infinity and infinity. And tangent inverse is defined between negative infinity and infinity. And the answer must be only between negative pi over 2 and pi over 2. So any other answer is not acceptable. So that's why we get negative pi over 3. So one more time for tangent, there are only two options. For the top angle, 1/2 divided by the square root of 3 over 2, which will not simplify. And the other one for the bottom angle is the square root of 3 over 2 over 1/2, which will simplify to the square root of 3. So that's why it's the bottom angle, the biggest one, which is pi over 3. Okay, another one, please. And then let's look at these triangles.
We do 11.
Let's do 11. This one.
Yes.
Perfect. Let's look at 11. Same page. And we have cosine inverse of negative the square root of 2 over 2. Perfect. Let me write the domain and range for this one too. So this is cosine is defined between 0 and pi, taking values between negative 1 and 1. And cosine inverse is defined obviously between negative 1 and 1. And the answer must be a positive angle always between 0 and pi. Now we know that this is a negative angle, a negative number. So it cannot be an angle in the first quadrant because cosine in the first quadrant is positive. So it has to be in the second quadrant. And it has something to do with pi over 4. It cannot be 1 pi over 4. It cannot be 2 pi over 4. It must be. Excellent. So then this is 3 pi over 4. It is a little bit weird, right? Because we know these functions are defined except tangent. They are defined everywhere. But we can't determine the inverse function if we are not restricting the domain. Okay. So I would like us to look at problem 30, and then we'll come back to others. On 686. And this is sine inverse of sine 5 pi over 6. Common sense here says, don't write it, please. But common sense here says 5 pi over 6. I'm applying the inverse function to a function. Obviously, this will undo what this one does. These will go away, and the answer is 5 pi over 6. Not so fast. In this particular case, I cannot use the property of inverse functions. Why? Because 5 pi over 6, 5 pi over 6 is not in the fourth or the first. It's an angle here. Can I still determine this? Yes, I can. So I will say sine inverse of, I have to find this number. As you said, it is indeed in the second quadrant. 5 times 30. Perfect. So this is 30 degrees shy of 180. So this is our 5 pi over 6. The reference angle is pi over 6. So sine 5 pi over 6 equals sine pi over 6. Sine 5 pi over 6 equals sine pi over 6 equals 1/2. So I have to calculate what's inside. And sine 5 pi over 6 is 1/2. Now I have the answer. And the answer has to be either the first or the fourth quadrant for sine. No problem. I know the sine inverse of 1/2 must be which angle? That's it. However, I couldn't use the property of inverse functions. But that's the obvious thing to do, right? This cancels that, and the answer is 5/6. No, you can't write 5/6. 5/6 over 6. So you can, because of the restrictions on sine. Okay. Let's choose any other problem from here. Which one? 34 it is. Perfect. In 34 we have sine of tangent inverse of 4/3. Perfect. Well, there is no point in discussing the property of inverse functions. Sine and tangent inverse are not inverses of each other, so I just need to determine this. And in this particular problem, it says, find the exact value, if possible, without a calculator. If not, if it is not possible, then explain why. I don't know what angle has tangent 4/3. I have no idea. It's not one of the listed angles of 30 degrees, 45 degrees, 60 degrees. We don't know. So in this particular case, I will not be able to determine this exact. Unless,
Is this the one where you do the triangle?
yes, you can. So we can do that. So we can do the triangle, which means this is the opposite and this is the adjacent. And the hypotenuse is 5. So then from here, we know that sine is, but I don't know the angle. So I can't say what the angle is, but I don't need it. So sine will be 4 divided by 5. But wait a second. I got carried away. This is tangent inverse. This is tangent inverse. If this would have been perfect, it would have worked if this were just tangent.
The opposite would be 3.
But I can't. I have to apply, I have to put in the graphing calculator. There's no way. So our tangent, okay, our tangent of 4/3. The answer will be in radians, as we know. So our tangent 4 divided by 3.
But you just put tangent on the inverse.
It didn't take it. Yeah, I did click on that. It didn't. Okay, thank you. Tangent inverse of 4/3. The answer has to be in radians, so it's 0.92 of a radian. And now to this I apply sine. So sine applied to the previous answer, and I get 0.8.
So is that going to represent your degree?
No, it's a number. It's sine. Sine applied to 0.9287 radians is a number between -1 and 1, which is 0.8. Now, if you want to determine the angle, I mean, we already had to. We had to determine the angle from the beginning. I couldn't determine this, so I had to find tangent inverse, which gives us the angle, and then apply sine to the angle to get 0.8. We had no other choice.
So why did you end up writing the unit circle, or writing a triangle? Was that if you needed tangent?
So this is yes. So only if I have this. If I have this, then it makes sense to look at the unit circle and continue from there. So tangent of 4/3, again, it doesn't make any sense. I couldn't use this. That's irrelevant here. I had to determine the angle. I had to determine what this meant, and this was 0.9273 radians. And then when I apply sine to it, I get 0.8. If you want to change 0.9278 into degrees, you can, but there is no point. We are only asked to determine that. Okay. We have 4 minutes left. I'd like to choose any problem you want from here. For the following exercises, find the exact value of the expression in terms of x with the help of a reference angle. That's the last problem for today. Which one?
Your choice.
No, I'm looking at 39 or 37 through 41.
No, let's go with 39.
Okay, let's do 39. So in 39, we have cosine of sine inverse of 1 over x. Can anyone tell us what this is?
Is that sine?
Yes, sine inverse. So sine inverse of 1 over x. Can anyone tell us what this is? Sine inverse of 1 over x. And what I'm asking is it a number or is it an angle? Very good, it's an angle. So this is alpha. So alpha equals sine inverse of 1 over x. I would like to apply which function to both sides? I would like to apply sine x to both sides. So I get sine alpha equals, excellent. So there exists a right triangle with an angle alpha whose sine is 1 over x. So there is a right triangle with an acute angle alpha whose sine is opposite over the hypotenuse. Can anyone give us the measure of the other leg? Hypotenuse squared minus the other leg squared. What am I really asked to find is cosine alpha. Can anyone tell us how much is cosine alpha?
X squared minus X over X.
Excellent. This is it.
That's it.
Easy peasy lemon squeezy.
So let me just go back for 1 second and we'll stop. When we're given something like this and you see sine inverse, you know that the answer has to be, so sine inverse is applied to a number and the answer must be an angle. So in this problem, we're really asked to find cosine of this angle. In order to determine that, we established that this was, you can give it any name you want, we said alpha. We applied sine inverse to both sides, and this clears the sine inverse, so we get applied sine. Sine of sine inverse is just 1 over x. And then we said, okay, there must be a right triangle whose sine is 1 over x, opposite over the hypotenuse. That enabled us to determine the other leg, and then we were able to determine what we're asked to.
Why did you need the other leg?
For determining cosine. Very good question. I was asked to find cosine. If I don't have the adjacent leg, I'm not able to find cosine. By definition, cosine is the adjacent over the hypotenuse. Very good question. Is that clear? It's a lot of work here, so I'm gonna put some information in a little packet for us so we can go over a few other things. It's a lot. It is. I'm trying to trim it down and just put out there just the important information. Mister, if you have any questions, if you want to work on anything,
I let it stay.